Okay, assalamu alaikum. This video will hopefully summarize the lessons 5.4, 6.1, and 6.2. Now prepare yourself for a long ride because I will explain every question we took in the past a week or two. That being said, we may begin. So, beginning with our first question, it's asked us to find the average. Find the average. Now, how do we do this? How do we find the average when they give it to us in this notation? Well, we have a function, which is GFT, and we have an interval. And in order to solve this question, we will follow a rule. And this rule states, let me just write it up here so that it's clear all the time. The rule is 1 over b minus a, then we write integral notation. It will be a to b, and then our function f of x dx. So this is our rule that we will be applying. Now let's actually start solving the question. Now in the interval, they've given us, this is a and this is b. And this is our function, which is GFT. So let's write here 1 over b minus a is 2 minus 0, which we all know is 2. Then we write the integral notation, 0 to 2, and then our function, which is 1 plus t dt. Okay, because it is to the respect of t. Now we will integrate 1 plus t. So if we have any constant number, the integral of it becomes what? It becomes x. So 7 integral becomes 7x. 20 integral becomes 20x. I hope this becomes clear. And in case we already have a variable, so for example x, to integrate it, we will increase 1 to the power. So this is to the power. Okay, let's just take x power 2 as an example. So we'll add 1 to the power, it becomes x power 3, and then we divide by the new power we have. So this is power 3, we will divide by 3. Okay, so let's continue. So 1 over 2 times integral notation 0 to 2. Now let's integrate 1 plus 2 plus t. 1 is a constant, so we'll just make it t plus t is power 1, so we will say t power 1 plus 1, which becomes 2, and then we have 2 now, so we'll divide by 2. Okay, now we may actually sub in our values here. So we'll sub in the upper value, which is 2, then we will subtract it from the lower value, which is 0. So let's just write here 1 over 2 times, we have t here, so let's put 2 plus t, we'll put 2 power 2 over 2. So 2 power 2 will be 4. 4 over 2 will be 2. 2 plus 2 will be 2 plus 2 will be 4, and divided by 2, you'll ask why didn't you do multiplication first, because there should be like parentheses around this. 4 divided by 2 will be 2. So this is our answer, which is 2. Okay, let's continue. Again here, okay, let's take 8 an example. So we also know, or should know at least, that integrals is the exact opposite of derivatives. Okay, so whatever we derive, it is the integral of the original value. Hence, we will solve question 8 by deriving e power t to see what original value it had. So the derivative of e power t, we know is e power t. Well, actually we can add ln e, but ln e equals 1, and anything times 1 is the same, so we don't have to write it. Hence, if we go the integral way, which is the opposite way, then it is still e power t. So the integral of e power t, and now that we have proved it, so you don't forget it later on, is e power t. It's the same thing. So let's write 1 over 10 minus 0, which is again 10. We will add 0 to 10 here, and then add our function, which is e power t. We've already found the integral of e power t. It's the same thing, e power t, and 0 to 10. This is time 1 over 10. So let's sub in 10 first. Becomes e power 10 minus, let's sub in 0 now, e power 0 divided by 10. Anything power 0 is 1. So e power 10 minus 1 over 10. This is our final answer. Moving on to question 9. So we have here f of x equals, well, yeah, obviously I forgot to add dt here, but that's not important. Or I mean, it is important in an exam. It will still won't affect your final answer. So this is our function, this is our interval. So 1 over b minus a, integral notation, a to b, and then our function is 2. So let's integrate 2. We said any constant integral of it will be just adding the variable with respect to the function. So this time it will be x. Now let's sub in let's sub in b, then minus it when we sub in a. So whenever we have an x, we'll put b, minus whenever we have an x again, we'll put a, divided by b minus a. Now we can take 2 as a common factor in the numerator, so it becomes 2, then here b minus a over b minus a. So obviously this and this will go together, which means our final answer is 2. Moving on to our last question, which is, let me just move this somewhere around here. 4x plus 7 over the interval, this is 3, 1 to 3. So again, we'll write 1 over b is 3 minus a, which is 1. So 3 minus 1 will be 2. Integral notation 1 to 3. And let's write our function, which is 4x plus 7. Again, I forgot to write dx. Now, 1 over 2 times, we will write integrate 4x. It becomes 4x. So this is power 1. We'll add 1. It becomes 2. Then divide by 2. 2 and 2 with the 4 will go. So it becomes 2x power 2. 2x power 2 plus again a constant, it will become 7x right away. Okay, let's sub in, it is not 0 to 10, that was the last question. It is 1 to 3. Okay, hence let's just leave the half for a bit, so half times. Now let's sub in 3 here. This may take some space. Let me just make the font a bit smaller. Okay, so whenever we have an x, we'll replace it with 3. So 2 times 3 power 2 plus 7 times 3 minus, now let's sub in 1 for each x. It becomes 2 times 1 power 2. This is not 2. This is 2 plus 7 power times 1. This half will be the same, so 3 power 2 will be 9 times 2, 18, plus 7 times 3 will be 21, minus, let's put this in parentheses, 1 power 2 is 1, times 2 is 2, plus 7 times 1 is 7. Let's put this in parentheses. So 1 over half times 18 plus 21 is 39, minus 20 plus 7 is 9, and 39 minus 9 is obviously 30, and 30 times half or divided by 2 will equal 15. So this is our final answer for this question. That being said, I hope that we finished the first question. Now our second question states, find the area under the region. Okay, so let's find the area under the region. In order to solve this question, we have our interval. This is A, this is B. We have our two functions, and in order to find the area under the region, we will subtract to find the difference between them, because we have one under, one above, or here between. So let's begin solving. Let's write here integral notation. So 0 to 2, and then let's write our first function, which is e power x, minus our second function, which is 1, and then dx. So let's integrate. So 0 to 2, let's integrate e power x. Again, we said e power x, integral will be still e power x, minus integral of 1, it's a constant, so we put x dx. Now we may sub in, it becomes e power 2 minus 2. This is minus, let's sub in 0 now, e power 0 minus 0, and we know anything minus 0 is the same, and anything power 0 becomes 1. And finally, e power 2 will be the same, minus 2 and minus 1 will be minus 3. This is for the first question. Starting on with the second question, we have under y, actually never mind. This question is too high level for us because it has ln, and we will have to solve by parts, and we have yet to learn how to solve by parts. Actually, we will learn this in lesson 6.3, I believe, and this is 5.4, so we still have a while to get there. Okay, so question 14, Mafi, as Mr. said. Between y, so this is our function minus second function, and this is a, this is b. Let's write it right away. So integral a is 0, b is 1. Our first function is x power 2 minus second function, which is x power 3. Yes, that's true. Now let us integrate, okay, well, actually dx. Let's integrate x power 2. So x power 2, we'll add 1, as we said before, it becomes x power 3, then divide by the new power, which is 3, minus x power 3 again. This becomes 3 plus 1 is 4, obviously, and then we divide by 4. Keep this in 0 to 1, or actually it should be like this because we already found the integral 0 to 1. Now, if we sub in 0, we know that anything power 0 will still be 0, and anything divided by 0 will still be 0, hence this whole thing will equal 0, so we don't need to sub in 0 because it's useless. But we will sub in 1, and we know that any one power anything, or 1 power anything is still 1, so this will become 1 over 3 minus 1 over 4. We may multiply or crisscross, so 4 times 1 is 4, 3 times 1 minus 3, then time between the two denominators, 3 times 4 is 12, 4 minus 3 is 1 over 12. That's how we solve question 15. Now let's just put this anywhere else. Question 16, we can observe that from question, okay, you can go away. From question 15 and 16, we can observe that question 16 is the opposite of question 15, because here we have power 2, this is power 1 over 2. This is power 3, this is power 1 over 3. Hence, what effect this will have on our answer, since our last answer was 1 over 12, positive 1 over 12, this will be negative 1 over 12. How do we know how to prove it? Let's prove that. Okay, you can go away, please. You can go up. Let's prove that 16 is just the negative sign of question number 15. Again, same interval, obviously, that has to be 0 to 1, and then x power half minus x power 1 over 3. We'll still integrate it normally, so let's add 1 to the power, x power half, so 1 plus half is 3 over 2, and let's divide by 3 over 2. Since we have a fraction over a fraction, the 2 will go up, hence the 2 will go here, minus same thing for 1 over 3, so x power 1 over 3 plus 1 becomes 4 over 3. Let's divide by 4 over 3. Again, same case, the 3 will go up, becomes 3x power 4 over 3 divided by 4. So let's write this, and it is in the interval of 0 to 1. Again, if we sub in 0, 2 times 0 will still be 0, 0 power 3 over 2 will still be 0, 0 divided by 3 will still be 0, so it's useless to sub in 0. We don't need to sub in 0. But if we sub in 1, let me just delete this. So we sub in 1, well, 1 power 3 over 2 will still be 1. So 2 times 1 will be 2. And 3 power whatever is still 1. And 3 times 1 is 3. So now let's do the same step as last time. Crisscross, so 4 times 2 is 8, minus 3 times 3 times 3 is 9, divided by, multiply the two denominators, 12, so 8 minus 9 is negative 1 over 12. And if we go back, what's the answer for question 15? Positive 1 over 12. So we did prove it that 16 is just the opposite sign of 15. Finally, we will solve question number 17. Now this is an interesting question because you have a trigonometric function, and we've never worked with integration with trigonometric functions before. But let's learn how we discover the integral of trigonometric functions without even knowing the rules. Just by knowing the derivatives, we will know the integral of sine x. So let's write our integral. So here, 6 to 10. So 6 to 10. First function is sine x plus 2. Second function minus here 0.5. Now to save a lot of work and steps on us, we will just add 2 and negative 0.5, which becomes 1.5. Now we know that the derivative of cosine x is negative sine x. And we know that integral is the opposite way, so we find the integral of sine x, it's the cosine. Okay? But we also cannot forget about the fact of the negative sign, so we'll still keep negative cosine x. So this is the integral of sine x. Integral of 1.5 will be 1.5x, same thing because it's a constant. And then we will sub in the b, then a. So let's write the values. Cosine, negative cosine x plus 1.5 at 6 to 10. So this will mean negative cosine times 10 because we have an x there, plus 1.5, there should be an x here, times 10, minus, now let's sub in 6, negative cosine 6 plus 1.5 times 6. We put this in the calculator and we get the answer. Now we finish lesson 5.4. So this is 5.4 done. Let us start with lesson 6.1. So in the lesson 6.1, it's very interesting, very simple and lovely lesson. We have two very vital and important rules, which are, and let me write them so that we don't forget them, because we will still need them when we start solving the questions. Here it says if, so use the if then language, if f prime of x is above the x-axis then, this is our then, f of x, aka our original function, is increasing. Let's take an example. We see that the function of f prime of x is above the x-axis from 0 to 4. Okay, hence the function, the original function f of x, should be increasing the entire time until the point 4, and only at 4 it should start decreasing. If you see here, this is the original function, and we have two initial conditions, which are f of 0 equals 1 and f of 0 equals 1. We see that from the interval 0 to 4, the function is actually increasing, and only at 4 it starts to decrease. Let's take another rule with another example. So if, again, if then language, if f prime of x is increasing, then, and this is our then, concavity will be up, or will be facing upwards. Okay, and vice versa, of course. Let's see this example. So f prime of x, we see that from the interval 0 to 2, from 0 to 2, the function is increasing the entire time. Okay, let's take the original function, and we will see that the function is concaving up from 0 to 2. Okay, as you can see here. And at point 2, and it has a name, don't worry, we'll discuss it. After point 2, we'll see that the function is decreasing. So from 2 to 4, it's decreasing, hence concavity is down. Okay, we must discuss also a very important thing that we have to mention, which are critical points. And we've learned critical points in lesson maybe 4.3, which is in the last chapter. Hence, you may forget about it because we took it last term. We took it during midterms. But critical points are basically, there will be a maximum and minimum in a critical point. So let's go to the maximum here, which is at 1 exactly. And let's go here, the original equation, and we see, look, 1 is actually on the x-axis of 1. We also should know that in a critical point, the slope will equal 0. So when does it cross the x-axis? At 3, 2. And if we go back to the original function, at 3, it has a minimum or maximum, as you can see here, at 3. Okay. I believe this summarizes this up. And to revise, let's solve this question. So, if f of x is positive over an interval, then the original, which is f of x, is what is, obviously, if it's positive, it will be increasing. Okay. Again, if f of x is increasing over an interval, then f of x, the original equation, is over the interval. We said if it's increasing, then it will be concaving up. Okay, now we can actually do the exercises. So in question number 5, we can notice that there's no increase or decrease, hence there won't be any concavity. But we also must give some attention to this fact, which is sketch two functions. Okay, so we have two initial conditions, which are f of 0 equals 0 and f of 0 equals 1, which means that we will start from, this is the y, so they want us to start from 0, I mean. And since it's above the x-axis, then the original function will be increasing. And same thing for here, for our second initial condition, we start from 1, it will be increasing. Same thing here, we'll start from 0, since it's below the x-axis, it will be decreasing, going that way. Same thing here, we'll start from 1, decreasing, going that way. Here's an interesting question. Actually, before we discuss this, let's discuss the inflection point that we find at 2, because I said we have a name for 2, which is the inflection point, and this is at 2. We see that the function transfers from concaving up to concaving down. You see, it's just in the middle between these two. The point 2, it's between the concavity up and concavity down two graphs, which means that it's undefined for a critical point, and we know that a sharp point violates one of the 3 differentiability rules that we have, so it all makes sense. That's why actually we can take this and never discuss question 8, because we never did in the class. Let's draw the 2 initial condition graphs for this. So let's start from 0 above x-axis, increasing until 1, and then it will jump, hence it will decrease from after 1 because it's below the x-axis. Same thing here, it will be parallel, so it will start from 1 and it will reach down. Again, this is critical point, also an inflection point, you can say, or not an inflection point, because in this case it's not, but it's undefined because it violates one of the differentiability rules, which is this discontinuity. Let's do we have any more? Yes, this is just the opposite, so it will decrease from the beginning and then it will increase after that. Again, for the second initial condition, it will start from 1, and same thing, it will be parallel to the first graph. Solving the last question, this is when we have a decrease or increase, which means we will have concavity. So it will be concaving here. It will be, since this is below the x-axis, it will be decreasing but concaving while concaving up, because the function is f prime of x is increasing at the same time. Half of it is under the curve, the other under the x-axis, the other half is above. So it will be concaving up under the x-axis until 1, and then we will start increasing after 1, as you can see here. Same thing for the second initial condition, we'll start from 1 and we will draw the same exact graph. Did we solve? Yes, we did solve. Okay, so I believe this, okay, well, I deleted something very vital and important here. Okay, I hope this works. So what's our question here? Let's go here. This will obviously come in the exam, just because I forgot to mention, this will obviously come in the exam. So let's discuss question number 2. So use figure 6.10, which is this figure, and the fact that p of 0 equals 0. I mean p equals 0 when t equals 0, to find the values of p when t equals 1, 2, 3, 4, 5. Let's go back. The way to solve this question, Kind of tricky because we don't usually do such questions, but we know that, let's say 0 to 1. Let's take this as an integral. The integral 0 to 1 of p of t. Okay. Obviously p prime of t, then dt. This will equal what? It will equal p of 1 minus p of 2. You'll ask why? Because we have here, we have here prime and we have integral. These two will cancel each other, leaving us with 0 and 1 subbing in with p of t. That being said, let's start solving the actual questions. When this is actually partially the answer, so I will just leave it here, and I'll just make it cleaner. Okay, so p of 0. So what does the integral of p prime of t from 0 to 1? It basically just tells us that in this graph of dp over dt, which is basically p prime, just like if you remember dy over dx, I mean t prime, sorry, we will take the area under the curve of 0 to 1, this interval. So from 0 to 1, see here, from 0 to 1, the area should be, the length and side is 1, 1, hence the area should be 1. So we can delete this whole thing and write 1 instead, which will equal p of 1 plus, or sorry, minus, was it minus or plus? It was, yeah, it was minus p of 0. And we know that p of 0 equals 0, hence anything minus 0 will be the same, so p of 1 will equal 1. So this is for this first. Second, we'll take the area under the curve of 1 to 2 from this interval. So integral notation 1 to 2, p prime of t dt will equal p of 2 minus p of 1. P of, so this whole thing, let's find the area under the curve. Again, length is 1, width is 1, hence the area will be 1. 1 will equal p of 2 minus p of 1, and we actually just got the value of p of 1, which is 1, hence we will remove this, we'll put 1 here instead. And let's transfer it to the other side because we want the value of p of 2, so p of 2 equals 2. Moving on to the third interval, it will be from 2 to 3. So let me delete some of the stuff here. So this is for 1 to 2. Now let's write the same thing again, integral notation, 2 to 3, p prime of t dt will equal p of 3 minus p of 2. Okay, so let's get the area under the curve of from the interval 2 to 3, which is only, we see this time, this is 1 and this is 1, but half of the square is actually gone, so it will be 1 divided by 2, which is half. So 0.5 will equal p of 3 minus p of 2. We just got the value of p of 2, which is 2. So we'll put 2 to the other side because we want the value of 3. So p of 3 equals 2.5. Let's change the color. So again here, same thing. We write the interval, this time 3 to 4. P prime of t dt will equal, it will equal p of 4 minus p of 3. Area under the curve from the interval 3 to 4 will be this time negative half, because this positive half is above the x-axis, but this half is below the x-axis. As you can see here, this is the area under the curve. So I don't care about the Mac Mini, I'm not rich enough. So let's write here negative 0.5 will equal P of 4, which we want to know, minus P of 3, which we already know. So we remove P of 3. Instead, we will write the original value we got, which is 2.5. Then we put it to the other side to isolate P of 4. So P of 4 equals 2. Finally, fifth, it will be from 4 to 5. And this is an entirely, like, this is the full block under the curve. Hence, it is negative 1. So if you write here the integral notation from 4 to 5, P prime of t dt will equal P of 5 minus P of 4. We said this we will delete, we'll put negative 1 instead. This is the area under the curve. And then P of 5, we do not know this information yet. Minus P of 4, we already know the information, which is 2. So let's put 2 and transfer to the other side to isolate P of 5. Hence P of 5 equals negative 1 plus 2, which is 1. Hence these are the values. So T1 equals 1, T2 equals 1 or 2, it equals. T3 equals 2.5, T4 equals 2, and T5 equals 2. 1, I mean, yeah. I was like, this doesn't make sense. Okay, moving on to lesson 6.2. We have a couple of questions, multiple exercises. Luckily, most of them we won't do, but let's find the let's integrate sine x plus 3 cosine x dx. Now we can actually isolate. It's like distributing the integral to sine x and 3 cosine x. So let's write it separately. So integral of sine x plus 3 integral of cosine x. We already discussed what the integral of sine x will be, which is negative cosine x, plus 3 will be the same, and integral of cosine x will be sine x. And this is our answer. So you can go here. Using the fundamental theorem, aka the adding 1 to the power, then dividing by the new power. So 3x power 2. So let's add 1 to the power. So 2. If we add plus 1 to the power, 2 plus 1 will become 3. Our new power is 3, so we'll divide by 3. And 3 divided by 3 will cancel each other, so they will be gone. Hence, we only have x power 3 left. Now let's substitute 2 for x. It becomes 2 power 3 minus 1 power 3. So 2 power 3 will equal 8, minus 1 power anything will be 1. Hence 8 minus 1 will equal 7. Let's now solve actual exercise questions. So we can put z up, it becomes z power negative 3. And then if we add 1 to the power, it becomes z power negative 2 divided by the new power, which is negative 2. Here again, this we'll discuss something interesting about 1 over y. But let's first integrate y power 4. It becomes y power 4 plus 1, which becomes 5. Now let's divide by 5. Plus, now we know that the derivative of e will give us ln. or sorry, the derivative of ln x will equal 1 over x. So the integral of 1 over x will give us ln x. Hence, the derivative of 1 over y will give us ln y. That's how we answer it. Integral of 5, we will just add x because it's a constant. We've said from the beginning. Integral of 1 over z, again, the derivative of ln x will be 1 over x, hence the derivative of ln x will be 1 over x, hence the integral 1 over x will be ln x. So integral of 1 over z will be ln z. The integral of z, it becomes z power half plus 1 becomes 3 power 2 divided by 3 power 2. 2 will go up, hence it becomes 2z power 3 over 2 divided by 3. Moving on to the last question that we have today. Actually, some of them are deleted, or not deleted, but more like we have yet to actually do. But before we actually, okay, so we have this question with us. This question is not with us. This question is not with us too. This question isn't with us. This question is not. Okay, so we have 1, 2, 3 questions left. So let us begin. Okay, so integral of 5x squared. As we said, we'll distribute the integral, so it becomes here 5 goes back, it becomes x squared plus integral to integral of root x. So 5x squared, if we integrate it, it becomes x power 2 plus 1, which becomes 3 divided by 3, and we will add the 5 there, plus 2 will be the same. Integral of x, root x will be, we already said x power half, we just did it, plus 1, it becomes 3 divided by 2, and then the 2 will go to the back, the numerator will divide. So it will be just like that. So 2 times 2 will be 4. Hence, we can just add the 2 values because the fractions are common. So it becomes 5x power 3 plus 4x power 3 over 2 divided by 3. This is the answer. Here again, we will write x power 3 over 2 plus 1. It becomes 5 over 2. Now let's divide by 5 over 2. And the 2 will go up. Minus, if we integrate this, actually 2 will go back, and then we'll have 1 over x, and we know integral of 1 over x is ln x, so times ln x. So this is minus 2 ln x. Move on to our last question, which is question number 55. We can actually take the integral of what we integrate apart. So x over x, we can isolate it, plus 1 over x, and now let's find the integral of this. So before we find the integral of x over x, let's simplify it as 1. And now it's super simple. So integral of 1 will be x, plus integral of 1 over x is ln x. That being said, I believe we are done with the review. I hope if there wasn't anything that you understood during the class, or you forgot, or you were absent, then you got to revise it in this video. Other than that, I hope you have a wonderful day, and thank you as always.